now, so I'll start the recording and share the screen. And you should be able to see my slides pop up just now. There we go. Okay, so hello everyone, and for anyone who doesn't know the Design Society, I'll just introduce them to you. So the Design Society is an interdisciplinary community of academics, industry practitioners with the goal of developing and promoting a robust, usable and scalable means of designing solutions to complex problems that a sustainable and globalized society needs to thrive in the 21st century. More practically, what that means is that we're 900 members from 48 countries around the world, and you might be able to spot some of your countries there, or even some famous Design Society members in the background of that photo. What the Design Society is about is access to different research papers and thesis, awareness of design-related events, calls and jobs, reduced publication fees, reduced event registration fees, and the ability to develop your career. We also have specific benefits for younger members, such as PhD summer schools, young members events, the ability to interact with your peers, and also specific resources for younger members as well. The easiest way to get involved with the Design Society is to join one of our special interest groups, which you may have an interest that aligns with them. And so if you're interested with that, you can visit our website and learn more about each of these groups and who's involved. And that is designsociety.org. And so today we're going to be doing a bit of a chat room on Prime VR2, which is a European project. And we'll learn more about it in just a minute on VR ecosystems and rehabilitation systems, but it goes even much beyond that with all the different people that are involved. Also to point out that the part of this project, there is a workshop coming up in March, so you can visit the Design Society website and get all the information and links to the website where you need to sign up and register if you're interested as well. So without further ado, I'll hand over to Philip, who's going to talk to us about the Prime VR2 project, and then we'll hand over to Georgie, who will also give his side of the project as well. Okay, so I'll just stop sharing my screen and I'll hand over to you, Philip.
Can you see my screen?
Yes, it came up.
Okay, so good morning, everyone. Thank you, Ross, for the introduction, and also for the Design Society for giving us this opportunity to disseminate our Prime VR2 project. The title of our project is Personalized Recovery through a Multi-User Environment Virtual Reality for Rehabilitation. Before going into the details of the project, I would like to briefly introduce from where I'm coming. So I'm academic at the University of Malta, which is located in Nisida. It's very close to Valletta, which is our capital city, and that photo was taken from my favorite swimming spot. Okay, so it's very close to university. It's the sole public and highest teaching institution in Malta, with its structures being in line with the Bologna process and the European higher education area. It has a long history, over 400 years, and there are over 11,000 students, including 1,000 foreign or exchange students. It's comprised of 14 faculties and several interdisciplinary institutes and centers. I'm coming from the Faculty of Engineering. So our faculty is composed of 6 departments, 3 in the mechanical stream and 3 in the electrical stream. And I'm coming from the Department of Industrial and Manufacturing Engineering. Over the past 9 years, I have been involved in a number of research-funded projects related to the development of high-value-added products. The first one is RibRidge. So over here, we developed a set of 3 implantable titanium alloy ribs, as you can see over here. That was done in collaboration with Mater Dei Hospital. In another project, we developed this very small device. I have it here in my hands. So it's a distillant for micro endoscope applications, and it's composed of 2 different components which are made from 2 different polymers. But we managed to produce that item in one single process. by injection molding in order to avoid handling, which of course it becomes an issue when you have small parts. In this project, which is the Speech project, we developed this innovative interactive device aimed for children with development language disorders in order to provide them with a more engaging experience during the speech therapy sessions. This is a current project that we have, is called Smart Lab. The aim here is to develop a smart user-centered product service system for evaluating and developing functional hand skills in children with cerebral palsy. Again, over here, we are taking the children at the center of the design process, and we are developing customizable wearable smart devices which can capture the movements of their hands whilst being immersed in an augmented reality environment. This is something different. It's not in the medical field. We developed this innovative comprehensive simulator, which is characterized by an adjustable motorcycle jig, as you can see over here. And the scope here is to develop this comprehensive simulator which supports the design of customized and safer motorcycles. This project currently is subject to a patent. So that's an overview. Of course, these projects were funded by the Malta Council for Science and Technology, most of them. And today, the main item of the discussion is the Prime VR2 project, which, as Ross mentioned, is a Horizon Research Innovation Action Program project under Horizon 2020. So what is the overall aim of the Prime VR2? To create an end-to-end integrated digital development platform to produce effective VR rehabilitation environments. More specifically, we have three main objectives. The first one is to develop a digital profiling of the physiological and biomechanical requirements of users. We have three target users, namely children with dystonia, post-stroke patients, and torso patients who have suffered a sports injury. Another aim is to develop customized VR controllers that employ deformable housing structures using the characteristics of additive manufacturing. Last but not least, we have to develop a VR gaming space with social motivational games to help users reach their rehabilitation goals. Of course, to achieve those multidisciplinary objectives, we need a whole area of expertise. In fact, as you can see from this diagram over here, we have 14 partners spread across Europe. We have 5 academic institutions, 6 SMEs, and 3 living labs. University of Pisa is leading this project, and its main role from a research and development point of view is to capture the data from the patient. Then we have University of Strathclyde, whose main aim is to provide expertise on additive manufacturing and product interaction. Then ourselves, University of Malta, as I'm going to explain later on, our main aim is to test the controllers. Then University of Oulu, our colleague Georgie will later on explain their role in this project. Then we have University College of London, whereby their role here is to provide expertise in VR-based interaction. Then when it comes to SMEs, Loud One Design, the role is to design the actual controller. Kerubel, the role is to develop the software side of the platform in particular in order to monitor the progress that the patients are doing. Then we have Flying Squirrel Games, whose role is to develop the gaming environment. Then we have Capitora Digital, with the role to develop the training required to use the controller, the platform, and the games. Crowd Helix, through which we are aiming to create a critical mass in stakeholders in the whole VR ecosystem. And then we have Inlocom Innovation, whose role here is to disseminate the project and also commercialize the results. When it comes to the living labs, these are providing us with the 3 categories of patients. So we have St. James Hospital. They are providing us with sports injured patients. Then we have Kinesoforum, who are providing us with post-stroke patients. And then Disability Innovation Hub, who are giving us access with children with dystonia. The project is spread over a period of 3 years. Currently, we are in month 2022. Central to this project is a human-centered design approach that we are adopting. It is characterized by four main steps. First, we have to identify the activities through which we are extracting persona. Followed by that, we have to classify and abstract the main movements of these target users. So we had to observe several therapy exercises to understand better what type of movements they will be subjected to. Then we have to quantify the movements, even the range of movement, the forces they are able to handle, and also the time required to do a particular exercise. Through those activities, we aim to generate a palette of control interactions in order to define exercises to be delivered. So let's start off with the data capture. University of Pisa developed a low-cost, easily deployable setup for 3D scanning, enabling clinicians to 3D scan the upper limb of the patients. It's good to mention that as a research boundary, we focused on the upper limb of the patients. We also developed a user profile toolkit through which the data captured, including the 3D scan data of the hand, finger movements, and force measurements, can then be utilized by the designer to generate the bespoke controller. So, University of Strathclyde is focusing also on testing of deformable 3D printed structures. So they devised this testing setup to examine deformable additive manufacturer structures, which are also integrated with CAD modeling environment. These structures will be applied within different controller functional elements. Of course, due to IP issues at the moment, I cannot divulge where and how such structures will be specifically used in our controller. When it comes to design activity, so Loud One Design created a lot of sketches. This is an example. So we are seeing here an ideation sketch. The controller is composed of various elements. Here we are seeing just its core module, but we have the therapy module, which is bespoke to different types of target users. And of course, to reduce the cost, we are trying to develop it as modular as possible so that the costs are reduced. As you can see over here, the main mode of interaction at the time being with the game will be wrist extension and flexion. So the therapy module, which will be attached to the score module over here, will mimic those movements. And of course, apart from the actual sketch and CADing, there have been a lot of work carried out by Loud One Design when it comes to prototyping. Focusing now on our role as University of Malta. So the overall aim of our package is to produce a mechanically sound integrated structure of the controllers able to incorporate all components and survive use in service. We have 8 main tasks within our work package. First of all, to establish material and product specification, apply design for manufacture and assembly methodology, manufacturing of support structures in order to support the electronics or integrate the electronics within the housing of the controller, assembly of the components to the housing, generate a verification, validation and test plan, design and build of the simulation test bay, which will mimic the actual operation of the controllers during the use phase, execute product validation plan, and finally, analyze the test results and provide feedback to the design. So one of our tasks was to see how or observe how design for manufacture and assembly guidelines are applied within state-of-the-art controllers. So when it comes to design for assembly, we refer to guidelines, existing guidelines, of course, and also we carried out a teardown exercise of 3 state-of-the-art VR controllers. Since our controllers are 3D printed, we looked at design considerations for additive manufacturing. This is an example of the HTC Vive. So we subjected the controllers to an X-ray to see how the different components are assembled. And then we disassembled them in order to generate what is called a product breakdown structure. And this is just an example for the controller base assembly. So the 3 existing controllers which were taken as case studies were the HTC Vive, the PlayStation Move, and the Oculus Touch. So the design for manufacturing assembly principles were observed in each of these controllers, and as conclusion, we saw that the PS move use the most DFMEA principles. This is just a summary of the main principles that we have observed in this exercise, teardown exercise and observations. Mistake-proof product assembly. Pins are used to guide components during the assembly. Vertical assembly, so most components can be assembled from above and have self-locating features. Alignment, a lot of features such as lips, ribs, and pins are used to align the assembly of parts. Tapers, which greatly facilitates the positioning of the different components. Joining, we have observed the heavy use of adhesive integral attachment methods such as snap fits and also screws, which are used a lot. Orientation, symmetrical parts for automatic feeding and also asymmetric parts for ease of orientation. So the general principles which are observed in other artifacts could also be observed here in such controllers. We looked also on additive manufacturing applications in VR bespoke controllers, so in particular 3D printing on textile material, how to fabricate embedded flexible smart sensors, and also how to combine pick and place systems to embrace the FA philosophy, because part of our manufacturing step and assembly step involves pausing the printer, inserting the components and continue with the printing. So we had to look also of current technologies, pick and place systems to this end. We also analyzed the first design iteration of the controller with respect to design for assembly manufacturing guidelines, for additive manufacturing guidelines. Here we are just seeing an example of the first iteration of the design and how standard design guidelines for 3D printing can be employed here. We also devised a comprehensive verification, validation, and test plan. We have, as the core of this plan, we used failure mode and defect analysis, as you can see over here. And it's good to mention that this plan will be presented in a few weeks' time at ISET in the paper titled Verification and Validation Testing Framework to Develop Bespoke Medical Products in Research-Funded Projects, because we observed that when it comes to research-funded projects, at least there is no comprehensive test plan in order to verify and validate a medical device which is 3D printed. This is just an example of how the design failure mode and defect analysis was employed. So first we have identified critical areas of the controller, and then we listed all the components and potential failures for those components. It's good to mention that in parallel with all these activities, we are working on a CE marking strategy, and the DFMEA and also risk assessment are very important tools to ensure that your device adheres to standards and therefore to have it CE marked. Hardware integration, so we supported all university in the modeling the core control electrical components to establish the layout of electronics enclosure, in particular when it comes to the battery, as you can see over here. Georgia later on will speak more on the activities carried out in our package 5. We also started analyzing the assembly of the first prototype. So far we have 2 iterations. The first one was in March, the second one was in May, and currently Loud One is working on the third one, which hopefully will be ready by September. Okay, so we analyzed the hand module, identified minor modifications, in particular when it comes to tolerances, as you can see over here. These are just pictures of problematic areas which we encountered, and mainly it was due to tolerancing. Okay, but of course changes are expected as we start analyze the new controller design. Something about the testing strategy that we are devising. So it's a 3-stage strategy. In the first stage, we are focusing on material analysis to understand the expected behavior from 10 small parts. Stage 2, testing on individual control features. These are components or sub-assemblies within our controller, the spine, the strap, wrist link, module interface, and finally, we aim to test the whole controller to simulate test-specific scenarios with multiple movements. When it comes to stage 1, we designed various specimens according to the 638 ISO 528 and 3D printed them for tensile testing. Specimens were printed in different orientations in order to facilitate the identification of weaker areas due to part orientation. And these are some photos illustrating the printing process. Further to stage 1, then the samples are tested at the moment for ultimate tensile stress, elastic modulus, and tensile strain in our labs. Results are in the process of being analyzed. And this is one of the samples. Then we have stage 2, testing on individual controller features. So that was at the material level. Now we are moving on the next level, which is testing on of the individual features. Again, here we are resorting to in-house testing machines such as the Instron compression and Instron tensile testing. Of course, we have to design jigs in order to fix the components within these machines. When it comes to stage 3, then testing the whole controller, we are planning to use cobots, which will mimic the movements of the end users. So that was just a snapshot of what we are doing in our package 4. Other activities in Prime VR2, Flying Squirrel Games have developed. At the moment, they have 10 gaming environments ranging from a greenhouse environment to a pub in order to, meet the expectations of the end users. In fact, we have also co-designed the games with the end users and also the clinicians. Then this is just an example of the web platform dashboard, where the clinicians and also the end users can have a look at the activity of the exercises carried out, the most played games, and other matrices which are used in order to monitor the progress that patients are doing. So those were the R&D activities. Of course, then there are the dissemination, cross-cutting activities. Prime VR2 is present on social media. We have also the website. So I invite you to follow our LinkedIn, the website, and also Facebook. As Ross mentioned, we are going to organize a workshop in Malta. It will be a hybrid event titled Design for Additive Manufacturing Future Interactive Devices. This event is sponsored by the Design Society, Maker Fair Malta, the Institution of Engineering Designers, and also Design for Additive Manufacturing Network in the UK. There is the link to the website, and over there you will find details on the program. Most it will be roundtable discussions on various themes on how additive manufacturing can be exploited to design the future interactive devices. As part of our efforts to create this critical mass of stakeholders in the VR ecosystem, as I mentioned previously, we are working on a self-sustainable research community around virtual reality and rehabilitation. There's the link. It is taken care of by CrowdHelix. We had the first event earlier this year as the workshop with EU-funded sister projects focused on solving health issues with IT, VR, and AI solutions. Currently, the VR Helix has around 287 users from 119 organizations, and we plan another VR event this year. Now, some challenges in such projects. Personally, it was my first experience. I had coordinated a lot national funded projects, but when it comes to this one, it was very different and more challenging. The spare diagram, for example, is just showing the dependencies of different work packages. These from work package 227, these are the R&D activities. Then we have the management, communication, dissemination, and exploitation, and data text requirement. And this diagram in itself portrays the complexity of handling such big projects. We have 14 partners. And the COVID pandemic, of course, did not help a lot. Imagine that we just met once in the kickoff meeting back in October 2019. Every problem or issue was solved in several online meetings. Of course, the COVID pandemic brought with it a number of challenges, delays in accessing or restrictions in accessing the laboratory, so we could not test as planned. We also learned that there are several issues concerning ethics, especially when it comes to this dystonic user group, because we are dealing with children, and also when it comes to CE marking. So in itself, it's a learning process. Some conclusions from my side. So Prime VR2 will result in development platform that integrates bespoke hardware and user-optimized gaming for enhanced rehabilitation. It will deliver a VR environment that allows users to socialize, play, and compare progress to aid motivation. It also provides non-invasive, accurate anatomical and mobility data collection that retain user dignity. Controller designs that incorporate external physical requirements and interactive features, and last but not least, a human-centered design approach to development and testing. So this marks the end of my presentation. Thank you very much for your attention. I look forward to receiving any of your queries. Thank you.
Thanks very much, Philip. And Georgie, do you want to share your screen now? And we'll switch over.
Yes.
And just whilst that's happening, if anyone has any questions, you can start to put them into the chat. And also just to say, I can see that we've had a few people join us into the meeting so they can ask questions and unmute their microphones. But there's another maybe 11 people, it looks like, who are in our guest room. In order to join us in the chat from the guest room, you will unfortunately have to leave the call and rejoin, but it's because you're not signed into your Microsoft account. So when you rejoin the conversation, rejoin the meeting, if you log into your Microsoft account, we'll be able to see you. But currently we can see Andrea, Charles, Meng, Pevan, and Siri Viathas. And if anyone else would like to join us in, just sign into your Microsoft account. Okay, thanks. I'll hand over to you, Georgie.
Thank you. I trust you see my screen now. Okay, so I'm Georgi Georgiev with the University of Finland. And we're working on primarily on Work Package 5, which is focused on device and interface design. We have several people working on this, but primary postdoc Vijaya Kumar in Japan and PhD candidate Yazan Barhush are in the team here, also several master students. Before going to the specifics, a few words about Oulu, University of Oulu. We are part of Center for Ubiquitous Computing, UbiComp. We are a rather small design research group of currently 7 people, not counting the master students, and we're situated in the northern part of Finland. This is a rather big faculty focused on information technology. And unfortunately, we cannot visit such places nowadays, but always a nice destination to visit either in summer or in winter. So the scope of Work Package 5 work is on the border of hardware and software. We are having several tasks with regard to the control and interaction aspects of the VR controllers. This includes electronic hardware design, connection to the virtual environment, interaction aspects there, and how these interactions are realized. We already saw the full diagram from Philip. This is our interactions between Work Package 5 and other work packages. Some of them are primarily delivering information to our work packages, but most of them are close interactions like work package 3 and 4, consort with the design and mechanical properties assembly. Later work packages 6 and 7 are concerned with the software and actual living labs where all the things are tested, realized, and so on. Our work involved state-of-the-art review of various existing systems focused on VR rehabilitation. That is to say, this included also systems with a certain degree of immersion. That means larger screens also are considered in this review. And from this, we understood various aspects, various existing implementations and trends in such kind of devices. They are implementing various approaches. For example, some of the approaches use existing hardware, such as existing controllers, VR controllers or gaming controllers. But other implement totally custom wearable or other complex systems for implementing rehabilitation approaches using immersive virtual environments. This is a very basic diagram of the system concept. So it consists of two types of controllers. One is the bespoke one, which is targeting the paralytic or injured hand, which includes different sensors, actuators there. And these targets detecting specific therapeutic interactions of the upper limb and delivering this data to the Unity environment, virtual environment, and where interactions are realized using the VR headset. We also have a controller for the other hand, which is targeting non-therapeutic interactions. That is to say, this has a fair amount of complexity because we have three totally different rehabilitation cases. So, for example, post-stroke rehabilitation, which might be one of the most complex one, has also a large variability of the cases among the patients. Probably the musculoskeletal injury rehabilitation, this is typically after sport injury, is more straightforward one, but is somehow similar to stroke. And then we have hyperkinetic movement disorders such as dystonia, which is targeting not particularly rehabilitation exercises or repetitive exercises, but realization of activities of daily living. So this highlights the complexity of the cases targeted by different solutions here, and we need bespoke controller for each of the cases, including different types of patients within each group, and this is particularly demanding in the case of post-stroke and then hyperkinetic movement disorders case. And then interactions can be different from for each case, scope of these interactions, degree, and so on. And these have to be realized with regard to the virtual environment and gaming environment in the virtual setting. Our work involves software aspects. This is covering both software on the controller level, but also software that communicates with the virtual environment with Unity and SteamVR. So here particular challenges are with regard to the control mappings, which are typically mapping movement or action into real world to the virtual environment action, and these are typically very different from the existing controllers because the requirements for each patient group and each particular cases of patient might be quite different. And then this is transferred to the virtual environment, the Unity input system, and in this case we are primarily using custom device inputs, which has to be designed case by case in order to realize particular action into the virtual environment. Examples we are seeing here are from our early work. I cannot disclose up-to-date things because some of these are covering intellectual property aspects of the design systems. We also have hardware that we have to implement. These are pictures of the early prototypes, which are designed to have certain inputs and outputs and deliver this or communicate these inputs or receive the outputs from the virtual environment. This also includes designing custom electronics and production of this electronics, implementing particular sensing mechanisms and actuating mechanisms. And with this work, we are focused on iterative prototyping. We have to test various sensing approaches, various actuating, different electronics functionality overall, and this has to correspond to the virtual environment interactions. We also have published few papers, including one to appear in ISET in a couple of weeks' time, which is focused on experimental design of a real-time VR tracking device. The earlier paper from last year is exploring some of the initial ideas for this project. The first one I highlighted here, published in International Conference on Design Creativity. Thank you.
Many thanks. And we will open up to any questions that anyone has. Either you can raise your hand or you can post it into the chat and myself or Freddie will pick up on that. But maybe just to kick us off, I've got a question for you both about my own interest in terms of how you manage the collaboration between all the teams, because it seems so complex and with everyone apart and the challenges of COVID. Are you using any particular technologies, and how do you share things like updates with each other? Is there any regular video meetings that take place? How does that all work?
Okay, Georgie, can I answer?
Yes, please. Yes.
Okay, so basically there are regular meetings held fortnightly in our case between work packages 3, 4, 5, and 6, because there is a lot of integration going there. So mostly we're using Zoom or Google Meet, so those are the two platforms. Then every now and then we have consortium meetings. Okay, and especially when a review meeting is coming, of course, we have to prepare well for that, because there will be very difficult questions by the reviewers. So in terms of internal collaboration, that's how things work. Then we have a cloud provided by University of Strathclyde. Okay, so we store the information over there, and we maintain regular contacts. Okay, we would love to meet physically, because unfortunately the COVID did not help a lot, as I mentioned. We went just once, so perhaps the rapport and that end needs to improve by physical meetings, but at the moment it's not that possible. Okay,
yeah.
So that's it.
Sure. Yeah, I think we all feel that with online meetings, you can get so much done, and it is very productive. But it's nice also to have that regular catch-up meeting once a year, just to collaborate in person and get things sorted.
What is also important to mention over here, Ross, in these projects is the importance of having a risk register.
Yeah.
So for each work package, we have a list of high priority risks, which we have to address frequently. I mean, we have to look at the risk register. Each work package leader has to look at the high priority risks, and of course, if there are risks which affect the others, they have to mitigate it as soon as possible.
Yeah.
So that's very, very important.
Very interesting. I see we have a question from Meng in the chat. I don't know if you want to unmute and ask the question yourself.
Yes, can you hear me?
Yeah, we can hear you.
Okay, thank you. Yeah, it's very nice and impressive presentations. My question is because you are mostly working on using a VR as a rehabilitation tool. So maybe can I ask too, because actually I am curious about it, because I have a colleague who is working on using augmented reality for also doing the upper limb rehabilitation. So why you were just focusing on virtuality instead of just not looking at the whole spectrum of the extended reality and see what are the effects? That is question one. And question two is, did you study the effect of virtual embodiment in rehabilitation? If yes, can you give some examples about the effect on mental and the physical strength? Thank you.
Okay.
Maybe I can try to answer the second question, which is about the embodiment in rehabilitation. We do not particularly investigate this aspect. However, some of the work done in the project is close to this aspect. For example, UCL is investigating so-called co-pilot VR, and this is approach of having additional helper in the virtual environment where particular challenging tasks are helped by this therapist or other kind of helper in the virtual environment. So this is not exactly embodiment, but certainly is kind of empowerment in a virtual environment for the cases, so for particular rehabilitation cases.
Okay, thank you. And
when it comes to the first question, I mean, the proposal was designed in a particular call. I think it was called Future Interactive Devices, and the scope was to specifically to develop a bespoke VR controller. So, I mean, we were constrained with the milestones and objectives of the proposal, rather than looking into augmented reality.
A very small addition here. Certainly, the project as currently is very challenging in terms of scope and breadth of challenges and tasks we have. And certainly, if we have AR or other XR technologies involved in this, it will be even more challenging. So I think it's good that we are focused at least on one of these technologies.
Yeah, okay. I think then it's quite understandable. And yeah, maybe I've from your presentation, the main focus is to really design the controllers for rehabilitation, especially for VR. I think it's very valuable work. So thank you.
Thank you.
Great, thanks, Meng, for your question. Do we have any more questions from the chat, or Freddie, do you have a question?
Yeah, I have a question. You, Philip, you were talking about the use of robot arms as testing your controllers, and I was curious to know whether or not you had to go out and capture the kind of mobility and forces that can be exerted by your target end users, because naturally they will vary quite a lot, I would imagine, from your average user. And I'm just curious to know how you went about replicating that interaction and the forces to be used with a robot arm.
Okay. So at the moment, we are just exploring that possibility. What we have is the data which we capture from a range of users using standard force measuring devices, which then are inputted in the user profile toolkit, which are then can be used in the design of the bespoke controller. So the aim at the moment, we have the personae of the different target users. Of course, we have to do a lot of more work to see how those can be mapped into actual movement of the robot. So we are working on them, because at the moment our efforts have been focused mostly on the first two stages of the testing strategy, on the materials that we're using for 3D printing in particular, because we have multiple materials, such as, for example, TPU and PLA, and it is not that easy sometimes to print both on the same part. So we are doing some tests also on the compatibility and adhesion between those two materials. And then at the moment, we started gradually stage 2, which is testing the actual component rather than the material level. Hopefully, I would say by September, when we have a more clear structure of the and idea of the design of the controller, will be in a better position to then map the forces that we have into the cobot and mount that controller with the cobot to do some tests. Again, this is just one option. It does not mean that the cobot will be used, or we are committed to use the cobot. Okay.
That's great, thank you. I guess a sort of follow-on comment perhaps would be that naturally with when you go down to control mapping, you've got a sort of similar a similar challenge with again considering the various physical abilities of each subgroup that you're addressing and how those might differ significantly. And do you foresee there being subgroups that you can code control maps for, or is it possible? My knowledge in this area is very limited, so this is curiosity more than anything, but whether or not there might be a point where you have to almost code control maps for each individual user. Is that something that that might be an issue, or have you figured out a way to mitigate that risk?
Yes. Georgie, would like to take this one?
Well, yes, for sure is custom per user. Control mapping is custom per user, and this is particularly strong customization in the case of stroke, and even more the hyperkinetic movement disorders, because there each particular case might be very unique, very specific, with very specific demands and let's say a range of movements, what is targeted, or for example, because hyperkinetic movement disorders, we are targeting particular activities of daily living. So the particular patient might want to target particular daily activity, which to be represented into a virtual environment. Then we have to design the particular control mapping between movement and virtual environment for this patient, for this activity. So it's very specific.
Wow, I can imagine.
Great, thank you. And we also have a hand up from, I think I'm pronouncing this hopefully okay, Srinivasan. Would you like to ask your question?
Yeah, sure. The pronunciation was perfect. No problem with that. Yeah. So first of all, yeah, thank you for sharing an interesting piece of work. So my question is, were you able to see any side effects of VR, both the hardware and the software, through this project? Because I mean, I don't know if you've tested it with patients as yet, but then it becomes more prominent. I mean, I did a very small scale project where I used VR. We developed a game for rehabilitating patients with spinal cord injuries. And one of the things that we found, of course, the side effects of the software part was they experienced nausea and vertigo after some time. and the hardware was particularly heavy on their head. So beyond 15 or 20 minutes, they really found discomfort around their neck, the head, and all that. So I was wondering if you also experience any.
Okay, so in terms of usability testing, we are still a bit far from that. I mean, what we did so far, we observed typical therapy sessions, okay, but we have also a prototype controller, which is second iteration, and it is being tested out with patients at St. James Clinic. We had already some feedback when it comes to the weight of the actual controller, because at the moment it looks a bit bulky, and we are striving to reduce the weight as much as possible, for sure. And also from feedback that we had from clinicians from the 3 living labs, they are suggesting that we don't use the VR environment longer than 3 minutes. Okay, so if you have to do some repetitions, you have to rest. You have to move the VR headset and then try the exercise again. But of course, it's subject to an evaluation, which we are planning in the last part of the project.
And just one small question, follow-up question. So for how long is your game designed to be played for in terms of the duration? The game that you talked about?
Okay, Georgia, perhaps you can take this one.
It depends on the patient group, and certainly the most challenging is the hyperkinetic movement disorders, and there we have set the duration of each sessions in matter of minutes, as Philip mentioned, 3 minutes or so. There are certainly several factors to consider here. One is typically the patients are very eager to try such things, but we have to be very aware of how long could be these sessions in order not to cause nausea. And certainly this also depends on the age group, because typically stroke patients might be older than the patient groups with musculoskeletal injuries, which might be able to have longer sessions without experiencing nausea and so on. Certainly this also depends on the fact if they have tried VR or have used VR previously.
Okay.
And the level of engagement is also crucial. That's why in the presentation we mentioned that we are trying to develop the games which are close to the likings and interests of the end users. And it's interesting to see different environments. As I mentioned, there is one which particularly struck me, the one of the pub. So imagine you are immersed in a pub, you meet your friends, and you take a cup, you move it in this direction to simulate wrist flexion and extension, but you are immersed in something which is different. It's not going to a clinic and carry out the usual traditional session. It's something different, and that has to be evaluated later on, as I mentioned. What I can say, at least from the feedback that we received from St. James Clinic, even the clinicians are looking forward and they are open to new ways of carrying out the therapy rather than sticking to the traditional approaches.
Okay,
Fantastic.
thank you.
Thanks very much. We've come to the end of our time just now, but I'm sure that if anyone has any questions, they can reach out to Philip and Georgie just by email or through the social media pages as well. Is that okay? Yep.
Yes, certainly.
Perfect. Fantastic. And so thank you very much for your presentation today, and thank you everyone for attending and suggesting your great questions as well. We will put the video of the session onto the Design Society website for members to watch and to rewatch if they would like. Also, just to mention again, the Defined workshop in March, and if you're interested in that, go onto the Design Society website and you'll see all of the links. And a final message, as Freddie reminded me, if you are attending the ISED conference, your video for your presentation is due on Friday, so there is an email being sent out today to remind you of this. So thank you very much, everyone, and indeed, I look forward to seeing you at ISET if you are attending.
Thank you.
Bye.
Thanks very much.
Everyone. Thank you.